Okay, in this last video in this kind of mini series on completing the square, we're actually going to look at how we can use it to solve. So completing the square, I really love the visual aspect of understanding that we're finding that area of the missing square to actually create our larger square. But we use this as a tool to be able to solve quadratics. So we know that we can solve quadratics by factoring. We can also solve quadratics by the quadratic formula. Those are great skills, but not everything factors, and the quadratic formula can be cumbersome at times. And so this is just another tool in our tool belt that allows us to solve quadratics. So here we're going to look at a very, very basic one. I could solve this by factoring. I know that I could factor out a 3 and an x. I have 3x squared. I take out 3x. That leaves me with x. I have negative 12x. I take out 3x. That leaves me with negative 4. And it's set equal to 0. In order to factor or use the quadratic formula, it has to be set equal to 0. I can then just take each of these, set them equal to 0, and solve them out. And I know that x is equal to 0 and x is equal to 4. But like I said, not all of them factor. So we're going to use the same one and show that we get the same answers on how we can use completing the square instead. So we know that in order to complete the square, we really want our a term to be 1. So the very first thing I'm always going to do is I'm going to divide out whatever my a term is. And even if I have ones that don't divide prettily, that's okay. We can deal with those later. I'm just going to immediately divide this out. That leaves me with x squared minus 4x. We know we're going to add something. 0 divided by 3 is also just 0. But this is where we have to remind ourselves, because we're dealing with an equation, we know that the golden rule of algebra says, well, whatever you do to one side, you must do to the other. So if I'm going to add something to one side of my equation, I need to be ready to add something to the other side as well. Now I'm ready to complete the square. I'm going to find my b term, which is negative 4. I'm going to divide it by 2. I'm going to square it. If this simplifies, which it does, I'm going to go and simplify it and square it. Negative 2 squared is 4. So since I'm adding 4 to the left-hand side, I also have to add 4 to the right-hand side. Now that I'm here, I'm ready to go ahead and finish my steps. I said in order to use this helpfully, you're going to need to be able to put this into factored form. So as a reminder, whatever this simplified to, whatever negative b over 2 simplifies to, that's actually what goes in your factor form. So this is negative 2. So I have x minus 2 squared, and then we'll simplify this side. 0 plus 4 is just 4. This is really useful because now look, I just have something on one side that is squared and just a number. If I have something like this, a square and a number, I can actually go ahead and square root both sides. This leaves me with x minus 2 is equal to plus or minus 2. So this is important. When we're introducing our square root, we know that we have to do the plus or the minus because 2 squared is 4 and negative 2 squared is 4. This actually gives us our two possible options, our answers. Notice up here we had 2. Anytime you have a quadratic, you'll have up to 2 answers. So the plus or minus allows us to find both of those possible answers. Now that we're here, we're ready to go. All we have to do is actually solve each of these out. So x minus 2 equals positive 2, and x minus 2 equals negative 2. So I'm going to add 2 to both sides, and I get x equals 4. I'm going to add 2 to both sides, and I get x equals 0. Notice that those are actually the same exact answers we got using the factoring method. So this is kind of the general idea of what we're doing. We get rid of our a term. We get it set up to where it's x squared plus bx. When it's x squared plus bx on this side by itself, we go ahead and complete the square. What we add to both sides, or what we add to one side, we add to the other. We actually go ahead and complete the square. Whatever's our simplified form here goes into our factored form, square root, and solve out. So we're going to do 2 more examples that are maybe slightly more complex, and I'll have those general steps here for you. So the one thing I want to do is I actually, once again, want to get it to be x squared plus b. And this one, notice that my b term is over here, and I have a constant over here. So the first thing I'm going to do is I'm actually going to switch those. So I'm going to end up with 6x squared. I'm going to subtract my 12x to the other side. I'm going to add my 15x to the other side. So that's what I've done. I've moved my constant to the side by itself, and I have my square term and my b term together. Now I'm going to divide by that a value, which is 6. 6x squared gives me x squared. Negative 12x divided by 6 gives me negative 2x. Now this is one of those ones where you can see that this isn't going to divide perfectly. 15 and 6 just don't divide perfectly. However, I do know that 15 and 6 are both divisible by 3. So 15 divided by 3 is 5. And 6 divided by 3 is 2. So I went ahead and I divided by a. Now I'm ready to complete the square. So I'm going to do x squared minus 2x plus something equals 5 halves plus something. In order to find that something, I'm going to do my b term, negative 2 over 2, square it. That does simplify to negative 1. Negative 1 squared is 1. Add that to both sides. Once again, I'm going to put this into its factored form. Oh, that's actually, bam, what we did there. Number 3 is go ahead and put it into your factored form. And so that's going to be x minus 1 squared. Once again, I'm getting that minus 1 from what my b over 2 value was. That's what goes into the factored form. That is equal to, well, 5 halves plus 1. That's 5 halves plus 2 halves, which is 7 halves. Now, we're ready to just go ahead and solve. At this point, we square root both sides. So that gives me x minus 1 is equal to the square root of 7 halves. I would ask myself here, can I simplify these? Well, I don't actually know the square root of 7. It doesn't simplify further. Neither does the square root of 2. But hold on, I can't forget my positive or my negative. So I'm going to go back and say it's actually positive or negative square root of 7 over 2. I can add my 1 to the other side, and I get x equals 1 plus or minus the square root of 7 over 2. For me, I'm going to leave my answer like this. There are other ways where you could simplify this further. You could get that 2 out of the denominator. But for me, I'm confident with this answer. You could also write it as 1 plus the square root of 7 over 2 and 1 minus the square root of 7 over 2 to show that you do actually have 2 different answers here. And let's go ahead and do one more. So same thing. The first thing I'm going to do is I want to move my constants. And as a reminder, a constant is just something without an x or without a variable. So I want to get those to the other side of my equation. So I'm going to subtract my 3 over. And this gives me 4x squared minus 12x equals 7. Done. I'm going to divide by my a term. So I'm going to divide by that 4. Done. That gives me x squared minus 3x equals, well, that's just going to be 7/4 for now, and that's going to be okay. I'm now ready to go ahead and complete the square. So I'm going to do x squared minus 3x plus something is equal to 7/4 plus something. In order to find that something, we're going to take that b term, negative 3 divided by 2, and square it. This doesn't simplify any further. So I know my factored form is going to be x minus 3 halves squared. Just getting that out of the way. I'm actually going to square it to figure out my blanks. So negative 3 squared is 9. 2 squared is 4. I did that. I even rewrote it in factored form, but I do need to simplify the other side. 7 plus 9 is 16. Divided by 4 is 4. That turned out prettier there. I was worried with the fractions can be ugly, but that turned out pretty for us. It simplified. And now we're ready to just go ahead and solve this. So we're going to square root both sides. We get x minus 3 halves equals the positive or negative square root of 4. So I get x minus 3 halves equals positive 2. X minus 3 halves equals negative 2. So notice here, because I actually knew the square root of 4, I went ahead and simplified it. Earlier, I didn't know the square root of 7 halves, so it just stayed as it was. And now we can go ahead and finish these. So I'm going to add 3 halves to both sides. 2 plus 3 halves, well, that's 4 halves plus 3 halves is 7 halves. Here, negative 2 plus 3 halves, so negative 2 is negative 4 halves. Negative 4 and 3 is negative 1. And there we have it. We have our 2 answers. So this is how you can use the process of completing the square to help you solve a quadratic instead of factoring or using the quadratic formula.